Hi, girls. All right. So, what you really missed from class is a review from what you did in Math 7. Nothing really too major quite yet. We started talking about this company called Stitch Fix, and we called this lesson 1.0 the Stitch Fix lesson. And this company, Stitch Fix, is like an online company that has stylists that choose clothes for you. And it's got some really great benefits to it. You get these 5 hand-picked items specifically for you. But as most things that are customized, it is quite expensive. So we talked about this company, and we talked about kind of why people would sign up for it when it's so expensive, or what are some of the benefits. But let me give you some background on this company. So this company, Stitch Fix, employs a person to pick out items from you based on a kind of a survey you take. And they charge a fee to be able to do this. So if you're getting one of these Stitch Fix boxes, you are charged a fee of $25. So that's kind of like their flat fee, what it costs. And then inside of the box are shoes and dresses and shirts and all these different clothing items that your stylist thinks that you might like. And the average cost on these items is not cheap. It's about $50 per item. So what we did was I asked the girls in class to model this scenario with an equation, a table, and a graph. So that's what we're going to do right now. So our equation. So the first thing we're going to do is look at an equation. So if you think about it, I have a $50 per item rate and a $25 fee. That means the scenario is not directly proportional. We're looking at an equation of y equals 50x plus 25. I'm starting with $25 and then I'm going up by 50 each time. So if I look at this in a table, an XY table, even if I buy no items from this company, I still have to pay that stylist $25, right? Because she is doing a service for me, right? And then every item I decide to purchase from that box is another $50. Now, they only put 5 items in your box. So in my X values, I'm only going to go up to 5 in my table. All right. And then on this side, I'm going to continually add 50. So 25 plus 50 is 75. Plus 50 is 125. Continually up. Plus 50 is 175. 225. And then 275. So in order to get a Stitch Fix box and buy all 5 items, the cost is almost $300. It's so expensive. So we talked about that worth. All right. Now, I also asked the girls to make a graph and graph the scenario on a table. Now, my X values are representing my number of items that I'm going to purchase. And then my Y values are going to represent the cost. So I'm going to ask you on graph paper, you're going to create a graph that is at least 5 this way. And then going up, I'm going to ask you to skip every graph, like every other. So this is my graph. You're going to skip every other and you're going to go up by 50s. And we're going to talk about why. So we have 50, 100, 150, 200, 250, and then 300. All right. Now, why 50? Okay, so that answer lies back into this table. Notice how we're going up by 50 each time. And on top of that, I have a $25 fee. If I go up by 50s, that second dash here is going to represent 25. And I just didn't write them all in, right? So it kind of makes it easier enough that I can graph all these data points. So let's start off 0, 25. And then we have 175. 2 is at 125. 3 is at 175. 4 is at 225. And then 5 finishes it off at 275. Now the next question is do we connect the data points? And the answer to that is no, because this is representing discrete data. Okay, so what is discrete data? Discrete data is data that does not have values between the intervals. So there are no values between the intervals. Okay, so what does that mean? So discrete data, there are no values between the intervals. So if I look in between these data points, there's half values. Can I buy half of a shirt? Like, can I say to the company, hey, I don't want to pay the full $75. I want to only pay part of it. Can I cut that shirt in half and send them back a half a shirt? No. So I'm not going to have any values that are off of these integer values. That's why it's discrete. When you connect the points, that is representing continuous data. And continuous data tends to be data that is like time. If you're running over time, you're always going to have a distance. 3.2 seconds into your run, you're still going to have a distance, right? You can measure into minuscule amounts. Height, right? When you're growing, your height is also representative of continuous data because you're not growing in intervals, you're growing continuously, right? So continuous data has data between interval points. And when we're looking at discrete items, usually it's items or students or people sometimes. So when the word problems are talking about these things, they tend to be discrete data. And continuous is like time or height, sometimes distance, right? So that's discrete and continuous data. We also looked at a scenario where the situation actually falls. So you can imagine if it's costing this much money, there might be some people who decide that they don't want to be part of this company anymore. So I talked about how they had 25,000 members, but it seems like every month their membership is decreasing by 150. People. All right. So what does this look like? So if I'm trying to write this into an equation, we're looking at y equals, I'm starting with 25,000 people, but every month I'm going down by 150, right? And I can look at this in a table of values similarly, right? I'm starting with, so no time has passed, 0 months has passed. I'm starting with 25,000 people. After a month, I'm going down by 150, 24,850. After 2 months, I'm looking at 24,700. After 3 months, I'm looking, sorry, 24,700. After 3 months, I'm looking at 24,550. 4 months, I'm looking at 24,400. And then continually, you can keep looking at this as the time decreases. All right. And then if you wanted to, you could actually graph this data as well. I'm going to try to make a very small graph. This is where you talked about, I think last year, using a break in your graph might be appropriate. If you think about it, getting up to 25,000 would be quite challenging. That's a lot of values to go up by. So if I use a break in my graph, I can start my data at 25,000, and then I can go down by my 150 each time. This one here, this value here, this value here, this value here. And then on this axis, we're looking at months. So 0, 1, 2, 3. If I can get it in 4. Okay. So we're looking at 25,000 to start, and I'm going down by 150 each month, right? And remember, a break in your graph is just the axis being smushed. It's like we're pushing this up. So we're looking at specific data above this x-axis, right? So this is a really great appropriate time to use that break in your graph. All right, so I hope that fills in some of the gaps. Take notes on this, and when you get back to school, we'll go over some of these problems in more detail. All right, have a good one, girls.